Okay, so this is on Simplex, and as difficult as it seems, it's important because the students that you're teaching are in programming, and this is really a row reduction matrix setup, but it's to let them see that no matter how complicated things are, there's still a way of solving these using a program. In other words, removing the brain that says, for instance, in equation 1 and 2, if I subtract, I will eliminate the x, or in equation 1 and 3, if I subtract, I'll eliminate the y. So the computer has no ability to do that. Usually I match these to the previous question, the one on graphing, so that it's a check as we go through that the values match starting at 0, 0. So first of all, standard form means that the computer has no way of dealing with less than or equal to. Well, it does, except it will not give us an exact answer. So, and I only do these on less than. So let's start by worrying about the equations in standard form. So it means that we're going to add a slack. So it'll be 2x plus y plus some amount will equal 18. In other words, when we work this, if it totals 16, because that's going to give us an optimal solution, then our slack in this equation 1 will be 2. And you can guess slack will not be the same for all of them. So we'll add a slack here. And we'll for the last one as well. So the number of equations will be the number of slacks. Now, I don't do greater than just because there isn't time, but you can imagine if it's greater than, we're subtracting the slack, because it means that we've got over what we want, so we would have to subtract it off. So each of these setups are called a tableau. So, and they will all look the same. You get them set up here. So we have an X, we have a Y, S1, S2, S3, and we can see that 3X and 2Y. So the values in our max Z equation is 3 and 2, and of course, whatever we don't produce, we're making no money on. So those will always be 0. So then we're going to put these in. Now there are different ways of setting them up. This is how I set them up. You just have to choose one and stick with it, or else it will be almost impossible for you to mark if somebody's adding and somebody else is subtracting. So first of all the slacks go in here. And just like in Excel, this will be 2, 1, 1, 0, 0, 18, 2, 3, 0, 1, 0, 4, 2, and 3, 1, 0, 0, 1, 2, 4. So this is our showing us the sum product now. So you can see the sum product, and I'll just write that so you remember how we connect it with doing it in Excel. So it's 0 times 2 plus 0 times 2 plus 0 times 3. So this is our Z value, the one that we found previously in graphing or in Excel. So these are always going to be 0. This is the origin if we go back and check in our graphical solution. And then C minus Z. So that's 3, 2, 0, 0, 0. Okay, so now we're doing a replacement. And our first job is to find the largest here. So that's going to be this one. And I'll dot that. And then we're going to divide each of these by what's in what I call the cloud. So this is 18 over 2, 42 over 2, and 24 over 3. Notice that I'm writing them on the edge and in a different color because the tableau has not changed. Those numbers are still 18, 42, and 24. Common mistake here is that the students will divide to see which one is going to come in and then replace it with the 9, 21, and 8. Okay, so the smallest is leaving. So you see, we have to have a method of being able to add and subtract, decide who comes and who goes. And we can't do it with us making a logical decision. It has to be a set rule. So this is it. We find the largest in our C minus Z. Then in the cloud we've made for that, we divide our outside edge, and for that the smallest goes. So here, this one. And this is called the pivot point. So you know, when you do matrix reduction, that point has to be a 1. So when we redraw this tableau, my last row is going to be X, and where that 3 is, I need to have a 1. This is an equation, so I'm going to end up dividing everything by 3. Let's just do that. Let me start again. I'll try to keep the colors consistent here. Oh, that's going to be a problem, but it's okay. Because we need to use the previous tableau. So this is going to be X 3, and I'm going to divide it by 3. This is my special equation now, my special line. So it's going to be 1 over 3, 0, 0, 1 over 3, and 8. Okay, so in a row matrix reduction, you know we're going to look for something like this, or some combination. Whatever, we must have zeros surrounding the 1. So I must have a 0 here. So I'm going to do it by some combination of my special line, the one I put the star in. So it's a 2. So I'm going to be doing this. It's going to be S2 minus 2 times my special line. That must give me a 0. So the reason I'm saying you need them on the same page, as you can see, I'm going to say 2 minus 2 times 1 is 0. 3 minus 2 times a third is 7/3. 0 minus 2 times 0 is 0. 1 minus 2 times 0 is 1. 0 minus 2 times a third is minus 2/3. And 42 minus 2 times, so let's write that one in. 2 times 8 is 26. So the next one, I also have a 2 there. So this is going to be S1 minus 2 times my special value. So S1 is also 0. I hope I can fit it in here. Just. So 2 times 2 times 1 is 0. 1 times 2 times a third is 1/3. 1 times 2 times 0 is 1. 0 times 2 times 0 is 0. And 0 minus 2 times a third is minus 2/3. And 18 minus 2 times 8 is 2. Oh, and I didn't write these top ones in. My goodness. These are the same each time. Okay, so now when we do our sum product, it's 0 times 0 for this green one, 0 times 0 for this green one, but it's 3 times 1 for the red one. So that's going to be 3. 3 times the third, because those are always going to be 0, will be 1. 0, 0, 1, 24. So this is saying that if, so the first time I was at 0, 0. Now I'm at 8, 3. Sorry, 8, 0. And the maximum I'll make is 24. So that was the second point in our graphical solution. So C minus Z, 0, 1, 0, 0, minus 1. I know I'm done when I have everything 0 or less. So I don't, I still have a 2 left here. So I need to write again. So let's set that up. And I'm going to choose, well, I'm choosing this one. Let me, and remember, I'm dividing by the cloud. So 2 divided by a third is 6. 26 divided by 7 over 3. Approximately 11. And this is 24. So this is telling me this one is going. And the pivot point is a third. So I will be multiplying that through. Let me to get this drawn bit now. So 3, 2, 0, 0, 0. And my pivot point must be 1. So this time I'll make my special line green. And I'm going to bring in y, so it will be y. But in order to make that third 1, I'm going to have to multiply by 3. So it will be 0, 1, 3, 0, minus 2, and 6. This is a special line now. So all the other ones, the zeros that I need here and here, have to be obtained by my green line. So S2. And in order to get 7/3 there, it's going to be S2 minus 7/3 of my green one. So 0 minus 0 is 0. 7/3 minus 7/3 times 1 is 0. 0 minus 0 minus 7/3 of 3 is minus 7. 1 minus 0 times 7/3 is 1. Minus 2/3 minus a minus 14/3 is 12/3, which is 4. And 26 minus 7/3 of 6 is 12. And for the next one, we have a 1/3. So it's S3 minus 1/3 of our special line. Yeah. Sorry about that. That should not have been. That is an X. So it's 1/3. So I'm starting with X minus my green 0 here. So it's 1 minus 0 is 1. And then 1/3 minus 1/3 is 0. 0 minus the third of 3 is minus 1. 0 minus 0 is 0. And 1/3 minus a minus 2/3 is 1. And 8 minus a third of 6 is 6. And Z. So now I'm multiplying in this one and this one. So this one will be 3. This one will be 2. Here I'm going to get 6 minus 3 is 3. 0. And minus 4 plus 3 is minus 1. And this is going to be 12 and 18 is 30. So this point is the 6, 6 with maximum value of 30. So let's subtract. And I get 0, 0, minus 3, 0, and 1. So I know I'm not done because I have a value greater than 0 in my bottom C minus Z line. I also know I'm not done if you had graphed it first because you know it's the next point. So let's set that one up now. So the only one possible here, this is the largest. We can't divide by a negative when we're finding these values. So the y is left out, but if I replace S2, this will be 12 over 4, and this will be 6 over 1. Cannot do. I'll write it like this so you'll remember. Obviously, you can't divide by 0 either. So the largest S3 is coming in, and it's replacing S2. So let's just set this up. And this time, this is the special line, I call it, and I replace them where they were. You don't need to do that. I just find it easier to go back and check myself, but there's no reason that needs to be done. So I'm going to now write in S3 in here, and I'm going to divide everything by 4. So that's 0, 0, minus 7 over 4, 1 over 4, 1, and 3. So I'm looking for zeros on both sides of these. So that means this time I'm multiplying by 2. So y plus 2 times the special value. So that's y. And it's 0 plus 2 times 0 is 0. 1 plus 2 times 0 is 1. 3 plus 2 times minus 7 over 4, which is really minus 7 over 2. So that's 3.5. So that leaves this minus a half. And then 0 plus 2 times this, and minus 2 plus 2 is 0, and 6 plus 2 times 3 is 12. And the other one is a 1, so it's just going to be a straight subtraction. So it's, I'm sorry, it's x. So 1 minus 0 is 1. 0 minus 0 is 0. Minus 1 minus a minus 7 quarters is 3 quarters. 0 minus 0 minus a quarter, and 1 minus 1, and 6 minus 3. So again, we're doing a sum product. 3, 2, minus a half, plus 9 quarters is 5 quarters. So, right, 9 quarters. No, minus 1 is 5/4, yes. And 1 minus 3/4 is 1/4. And this is 0. And this is 24 plus 9 is 33. And when I subtract this time, I get 0, 0, minus 5/4, minus 1/4. So the solution will be 312 with a value of 33. And that's what we got in the previous section.